For a long time, whenever I have been working on the computer, I have felt like something wasn't quite right. When I'm programming, even if I spend a lot of time writing comments and documentation, it's still hard for others to grasp my overall intention. I often have to explain the code design face to face. It's the same when I try to read someone else's code. It's incredibly difficult to understand the big picture, and you just get overwhelmed by endless tiny details. When I'm making a video, I have to constantly switch between many different pieces of software to handle the images, sound, editing, and special effects. I'm forced to break the work into many small, unmanageable project files, even though, in my mind, they truly belong together as a single, cohesive entity. These two problems seem unrelated, but if you look closely, you'll find they share an internal commonality. We think we are the masters of all tools, but we are actually limited by them. We are forced to organize our digital projects based on the tool's inherent structure instead of our design intent. A few years ago, I have been working on a flow management tool to solve this problem. I wasn't quite clear on the problem's definition initially, so my solutions were all over the place. After many failed development iterations, I finally started to understand the core issue. Here is my theory. This is our digital project, just a bunch of files. When we use a software tool to modify the project, we create some modification of these files. We call this a new version, and this is the old version. The process of modifying one version into another is what we call an iteration. We can continue to iterate on the new version, forming a chain of versions. We can also apply different iterations to the same version, which forms a branch. Furthermore, by comparing the file differences between two branches and their common ancestor, we can merge the two branches, forming a version that contains iterations from both. Up to this point, these are all features already implemented by version control systems like Git. Now we can discuss what's missing from the entire process. How do we record the intent behind the iterations? In the simplest scenario, the intent and the iteration correspond one-to-one. This is what a git commit message does. It allows you to use text to describe what modification was done in each iteration. But as you can see, this feature is quite limited. Let's make some analysis here. When we use the word intent, we are usually describing something unfinished or yet to be realized. This is clearly different from the commit message, which is written only after the iteration is complete. Second, intent can change. When we realize our initial assumption weren't correct, we need to revise the intent for the work we are doing. These revisions can be large or small, but the point is that they show the mapping from intent to iteration can be almost arbitrary. The same intent might undergo adjustment and span across iterations on multiple branches. Finally, intent is subjective, while iteration is objective. The same iteration can be analyzed from many different angles to understand its actual effect, or you might only choose to emphasize a modification to one specific part. So, what exactly is intent? Here's my definition. Intent, I believe, is simply a story. What makes it different from the general story is that it revolves around versions and iterations. We can use it to plan how iteration proceed, to describe the context of version development, or to compare the differences between different branches to analyze the best approach. As long as the story itself is reasonable, you can organize the project however you wish. That's enough abstract theory. Next, I'll use a more concrete application scenario to explain how this workflow should be used, and how it differs from existing version control systems. It's important to note that while I'll use a programming context for the explanation, the principles aren't limited to coding. They apply to all kinds of digital projects. Suppose you want to develop an application. You have a rough idea of its features and the potential paths to implementation. You can simply record this in the document and immediately start coding. After a few versions of iteration, or whenever you feel you have made progress worth noting, you can cite a specific version within the document. This could be pasting key code snippets directly from that version or linking to an executable demo program. Any operation executable within that version can be performed. The crucial part is that the document tool can access all files of all versions simultaneously without switching to a specific version. This means you can freely string together the development logic within the document tool, using the actual data from the versions to record your intent. Unlike API document or design documents written for a specific current version, this intent recording document will never become obsolete. Why? Because even if the core design intent changes, the adjustment is usually built up in the initial design. This means it's hard to understand the revised design without first understanding the flaws of the previous one. So you can probably already feel what kind of system I'm describing. It's a document tool, but that's not its most important attribute. The most important thing is its ability to access any file in any version at the same time, thereby binding the intent to the real version data, ultimately achieving the goal of recording intent. For the technically proficient among you, once you grasp the key point, you could theoretically build the system I'm describing. In principle, nothing stops you from implementing such a document tool on top of the existing version control systems like Git. However, to truly extend this tool beyond the field of programming, more work is needed. This brings us to the next part of this video. The obvious fact is that outside of programming, not many people use Git. There are many reasons for this, such as its difficulty managing binary files, the lack of effective hypertext comparison mechanisms, and the fact that Git's interaction flow isn't friendly enough to non-programmers. Therefore, if I were to bind the solution to Git from the start, the system would simply inherit all of Git's shortcomings, and that's not what I want. To illustrate how this system should be designed to extend beyond programming, let's look at the non-coding workflow. Consider the process of creating this video itself. To make it, I have to write the script, translate it into English, not a native speaker, draw graphics for every segment, record all the audio until every sentence sounds right, and finally put everything together in the editing software. I'm detailing these steps not to complain about how much work goes into making a video. Instead, the real issue is that, to move on to the next step, I have to make sure the previous one is essentially finished, so I don't have to keep switching between different software, making already chaotic file management even more messy. This isn't free creation, it's a production assembly line. If each part of the assembly line had a different person handling it, this might be fine. But when the entire line is run by a single person, it creates a massive amount of unnecessary friction. So how do we organize a project around the intent in this scenario? Let me paint a picture. First, we outline the video's general content and prepare the corresponding image, script, and audio assets. Initially, all assets can be very rough, just barely enough to assemble a rudimentary video version. Next, we implement the core mechanism. Make every single asset has its own independent version history. This is crucial because it means we can iterate on parts we want to improve in any order, until we think they are good enough for the final product. This workflow allows us to convert multiple separate asset projects into a single, unified whole that focuses on the core creative intention, and effectively eliminates the fragmentation of the creative flow caused by the old, forcibly divided assembly line work. And notably, this overall iteration process, just like in the programming scenario, can be recorded using the document tool. This helps us reflect on our creative direction, and we can also use the branching feature to explore different possibilities. Even better, once we can use this process to create any content, it will, in turn, enhance the capability of the document tool itself. Because the intent document is also a form of digital content, it doesn't have to be limited to the rich text format. It could be a nonlinear document, a mind map, a presentation, a video, or even some form that no one has explored yet. However, before we can fully implement such a powerful process, we need to solve two key problems. First, the tool switching cost. The workflow tool itself cannot completely eliminate the cost of switching between different pieces of external software. At best, you would have one interface for managing all your projects, but if specific work would still require switching to the corresponding software. This is practical for some scenarios, but it's still insufficient for more granular work, not to mention the excessive memory usage that comes from opening many projects simultaneously. Second, managing references. Our version control tool needs to help users easily manage a large number of referenced projects. For example, a video project needs to be able to reference an image asset project. This is difficult to do using Git submodules. You have to admit, it's not a very easy thing to use. Solving these remaining roadblocks requires rethinking of the current approach, and this brings us to the third part of the video. The design choices here might seem quite radical, but I believe I have done enough groundwork to explain their underlying rationale. The core logic is actually very simple. Since calling the external tool makes it hard to unlock the system's full potential, why not develop our own editing tool directly within the system? We have the intent document to manage the development of the editing tools, and any problem that arises during actual use will feed back in as new intent. Note that this is different from general issue tracking. The reporters can cite the actual problematic projects, and the developers can check whether the problem is truly solved in the actual project immediately after the fix. The structural level of the entire process will be unprecedented. Everything can be recorded, and everything can be traced. I know this sounds like a never-ending development expedition, and it genuinely is. On this point, I think I need to stress that even simple tools can provide powerful results. For example, we don't need to implement a complete image editing suite like Photoshop. Simply creating a basic drawing board is useful enough within the whole workflow. The same goes for other types of editing tools. Think about the 80-20 rule. 80% of the effort is achieved by 20% of the features. Therefore, even if the entire development process can go on indefinitely, we can make the entire system highly effective right from the early stages. And that is the most critical thing. That addresses the first problem I raised. Regarding the second issue, the user experience of handling a large number of project references. I can't offer a complete solution yet. However, I can briefly discuss the general direction of my thinking. While current digital projects are mainly organized using single project files or folder structures, I fundamentally believe that all digital work can actually be described using a graph structure. This is a data structure where an edge can connect any two nodes. We have already used this structure many times to describe the relationships between versions. Now I want to go a step further and organize the digital projects themselves as a graph. The benefit of doing this is twofold. First, the graph structure offers powerful descriptive capabilities. It can represent the structure of assets being transformed into output via operations in a digital project. Those familiar with node editors should quickly understand what I'm talking about. The second major benefit is unified management. Since both the project's own structure and its version relationship are graphs, we can use a unified graph editor interface to manage everything. For example, let's say we have a video project. The top-level graph is the version relationship structure of that video project. A specific version, which is the concrete video project, is also a graph. It references various image and audio assets. These assets can be simple files, or they can be editable projects. In that case, The asset is a reference to a specific version of that referenced project. We can expand its project graph structure at any time to edit it, which automatically advances the referenced project's version and updates the corresponding reference in the main video project. To make this more tangible, here is a very early prototype. Let me walk you through the project structure I just described. This is the general graph editor interface. Currently, it shows the version history graph of the video project. Watch as we click in. We are now inside a specific video project. It contains some file assets and some references to other projects. Opening one of those references reveals that referenced project's version structure, and continuing to open it allows editing the specific content of that project. I hope this helped you understand the solution. In fact, this prototype includes many other interesting features, but since this video is already quite long, I'll save those for a future episode. So this is essentially my complete project plan. Thank you so much for watching this far. My ideas for this project have changed a lot over the years, and this is the first time I have articulated my thoughts on this problem so completely. It also marks a major shift in my development thinking for this project. For a long time, I felt I should complete and release this project entirely on my own, but now I feel I need to share my ideas publicly. To be frank, I genuinely need feedback and support to finish this project. I have been working alone for too long, and I have to some extent become trapped in my own thinking. I really hope this video can be a new beginning for me. If you would like to participate in the project discussion, you can join my Discord. The link is in the video description. If you feel my content is worth supporting, please consider buying me a coffee. I will update my development status as quickly as possible. Although I can't promise a fixed update schedule right now, I hope to eventually update this channel consistently. See you soon! Question: if AI generation becomes increasingly important, will this workflow lose its value? I understand the concern, but I believe the opposite is true. In that scenario, this workflow will become even more crucial. I believe creation should be a traceable process, not just a result thrown out by AI without any context of lineage. Therefore, teaching AI to use workflow tools like the intent document is highly meaningful. For example, in a scenario where AI generates code, simply getting working software is far from enough. We need to understand the code's functional boundaries, potential failure scenarios, and even design pitfalls. I believe my workflow tool can effectively fill this gap, and even improve the quality of AI output through self-reflection. Question: are there any existing software similar to the intent document? If we talk about the primary goal of recording intent, I don't believe such a direct equivalent exists. However, if we look at the specific features or organizational forms, a few pieces of software align well with my understanding of the intent document. First, there is Storybook. While it's primarily a testing tool for React, it also serves to illustrate code functionality using simple working UI examples. This meets my expectation that the intent document should include executable, practical demonstrations. Another example is Decker, which is a multimedia platform for creating and sharing interactive documents. Its community has a practice of packaging code, documentation, and runnable examples into a single distributable file. I think this is also a highly commendable design. Although I mentioned these examples, I actually only came across this tool after completing the design for the intent document. Therefore, they didn't influence my design choice. If I had to name one software that significantly influenced me, it would be the code editor on the ShadowToy website. It showed me, in a very intuitive way, how a tight feedback loop can impact our coding mindset and efficiency. That experience truly ignited my desire for a more efficient workflow. I also have a great example to back up the point that simple tools can be incredibly useful. That is Flipnote Studio, a small tool provided by Nintendo on the 3DS, known in Japanese as Ugoku Memocho. If you search using the keyword Ugo Memo, you'll find people have created many astonishing animations with it, especially music videos. Although this example might be considered subcultural, my point is that when the purpose is creation rather than completing a specific task, simple tools can sometimes spark more creativity due to their flexibility. Question: why is the resolution of this video so low? Well, that was unintentional. I chose Wiggly Paint as my paint tool, which only supports this low resolution, and it has only 3 colors. This made it really difficult whenever I want to add text. However, since it's the only tool that easily allows me to achieve this specific wiggly pixel style, I suppose I don't really have a choice. Maybe in the future, I will implement my own tool to solve this problem.